And the first problem, it says cosine of 5 pi over 4. Now, we talked about how to do this without a calculator. We know that pi is 180 degrees. So pi over 4 we talked about was 45 degrees. 45 times 5 is 225. So you don't have to do a unit circle. The way we talked about doing these together is we draw it out. So 225 would be past 180, but before 270. So 225 would be right here. The important thing is that you could figure out the reference angle. Reference angle here would be how much more to get back to the x-axis. This would be 45 degrees, 90 and 45. So we have 1 and root 2. Remember, anytime you go left or down, that side is negative. And the reference angle is this right here. So you have the hypotenuse side, the opposite side, and the adjacent. The problem's asking us for cosine. Cosine, you should know by now, is adjacent over hypotenuse. So negative 1 over root 2. And then rationalizing this by multiplying by the denominator gives us negative root 2 over 2. That would be how you do a problem like that. For the second one, the tangent, if you remember tangent, that's opposite over adjacent. Pi over 3 is 60. So this is the same thing as 5 times 60, or 300 degrees. 300 degrees is past 270, but not quite at 360. This would be 300 degrees, giving us a reference angle of 60, which means this other angle is 30. And then what we do is we label the sides of the triangle like we talked about. This would be 1, 2, and root 3. Anytime you go left or down, that side's negative. So we have our reference triangle. This would be the hypotenuse side. This is the opposite. This is the adjacent. So tangent would be opposite over adjacent, or just negative root 3. For letter C, we have pi divided by 2. What did we say pi was? 180, right? 180 divided by 2 is, so this would be really the cosecant of negative 90 degrees, which is right here. Negative 90 degrees happens to be a quadrantal angle, which, remember, these are all 1 unit from the origin. So this would just be 0, negative 1. Sine is the y value here. Cosine is the x value. Tangent is y over x. And then we have CSC. Cosecant would be 1 over y. Secant's 1 over x. Cotangent would be x over y. So the cosecant here would just be 1 over the y value, or just negative 1. That's how you'd figure this out. All right, so that brings us to 765. So 765 is a really big number. We talked about quadrantal angles. And what we could do is just take 765 and subtract 360 from it. So 765 minus 360 is 405, but that's still pretty big. So the way that we talked about handling big angles, again, is we just use quadrantals. So we subtract 360 using coterminal. So when it's all said and done, just keep subtracting 360. You could have also kept adding 360. but we're left with 45 degrees, which is right here. 45 degrees is right here. This would be 1/√2. Sine would be opposite over hypotenuse. Multiplied by √2 over itself, and this would just be √2/2. For number 2, it talks about from the bottom of a 20-foot lake. So here's water, here's a fish, and we know that the lake is 20 feet. A bass could see a fisherman's boat 45 feet away. So here's the boat, and this will be drawn for you on the test, just so there's no confusion. But this is 45 feet. Find the angle of elevation from the fish to the boat. Angle of elevation means if you look straight ahead, angle of elevation is going up from straight ahead. So that would be this angle right here. Well, we have the opposite side, and we also have the adjacent side. So using trig, in trig, the opposite and adjacent is tangent. If we take the tangent of this angle, we'd get the opposite over the adjacent. And remember, we talked about using inverse trig in order to solve for angles. So what we could do at this point is we take the inverse tangent of both sides. If you have a calculator, you should type this in. You want to make sure your calculator is in degree mode. And if you type in inverse tangent of 20 divided by 45, you get 23.96 or 24 degrees.
Which one are they going to push?
So they is going to be me. I'm going to be grading this. But yeah, 20, either one is fine. Either one is fine. But just remember, if you don't put the degree symbol, that means radians. So 24 degrees is different from 24 radians. So the moral of the story is just make sure you put a little degree symbol. Question? Inverse, when we're solving right triangles, inverse gives us angles. And whenever you use like regular trig, which we're going to do in the next problem, this is going to give you sides. So for this particular problem, we have tangent of theta. We want to get theta by itself. So to get rid of tangent, you take the inverse tangent. That gets rid of it. Questions? Any other questions? Okay. Problem number 3. Find the values of the 6 trig functions of 2, -4. So what this means is we're going to go to 2, -4, which is over here, and draw a triangle. So we talked about drawing these kind of triangles that come out of the origin and then connect to the x-axis. So this would be 2, and this would be -4. The only thing we're missing is the hypotenuse in order to answer these. To get the hypotenuse, we could do 2 squared plus -4 squared is the hypotenuse squared. 4 plus 16 is the hypotenuse squared. Hypotenuse squared is 20. And hopefully we know how to reduce radicals. This is the same thing as the square root of 4 times the square root of 5. So the hypotenuse would just be 2√5. If it helps you, you could kind of draw like a fresh triangle off on the side here. This is the angle. Remember, the angle is always up against the x-axis. And from this angle, we know the opposite side is -4. The adjacent side is 2. And then the hypotenuse is 2√5. All right, so now we could go ahead and answer these 6 questions. Sine is opposite over hypotenuse. -4 over 2√5. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. The way we get the other 3 is we take the reciprocal. So cosecant would be 2√5 over -4. Secant would be 2√5 over 2. And then cotangent would be 2 over -4. But we always have to simplify. So when we're talking about simplifying, you can't have a radical in the denominator. So what we're going to do here is multiply by the radical. And this just turns into, well, 2 cancels out with the 4. So it's just -2√5 over 5 would be the final answer. -4 divided by 2 is just 2. For cosine, I know that this 2 cancels out with this 2, and we just get 1 over √5, which you want to multiply by the radical to just get √5 over 5. And this reduces to just be -2. Simplifying this, the 2 goes into 4 twice. So this would just be √5 over -2. The 2's cancel and we just get √5. 2 goes into 4 twice. So -1/2. How you do that problem. For number 4, we have a central angle. You have to remember the formula for this. The measure of an arc is equal to the radius times the angle in radians. So it says that the angle that we're using is 25, but we can't use that in a formula because the formula has to be in radians. So what we're going to do is take 25 degrees and convert it to radians by multiplying by pi over 180. We talked about doing this in class. You just type in 25 over 180 on your calculator and you get 5 over 36. If the diameter is 34, the radius would be 17. So we're going to do 17 times 5 pi over 36. And if we type this into our calculator, 17 times 5 over 36. Like the answer is just 85 pi over 36. That's what the answer would be. I got that on the right, and that's when we're converting from degrees to radians. If you want to get radians, you multiply by pi on top. So what you're going to do on your calculator is you type 25 over 180. So on the calculator I recommended that you get, you type the 25 and then hit the ABC button and then type 180, and it'll automatically reduce it for you when you hit enter, and it'll say 5 over 36. Yeah. Okay, go ahead. Good luck. Anyone else have any questions with this problem? Moving on to number 5, it says convert the angle into radians. Well, we said if we want to get radians, we take our angle and we multiply by what we want over what we don't want. So again, on your calculator, let's type 160 ABC 180, and my calculator is going to say 8 over 9. So the answer is 8 pi over 9. When we're talking about what quadrant it's in, so 160 degrees is positive, so we're going to pass 90, pass 180. 160 is going to be somewhere in the second quadrant. Remember, quadrants go 1, 2, 3, 4. So we're definitely in the second quadrant. When we're asked for a positive coterminal angle, what that means is you take 160 and you add 360. And when you want a negative coterminal, it's 160 minus 360. 160 plus the 360 is 520. And 160 minus the 360 is negative 200. Those would be a positive and a negative coterminal angle. And then the last thing we have to find is the reference angle. Reference angle means how close are you to the x-axis. It has to be positive, less than 90, and connect to the x-axis. Well, we already went 160 degrees, so the reference angle would be 20 degrees more. All right. Moving on to number 6. All right, for number 6, first question is to convert it into degrees. And what we're going to do in order to do that is you multiply by what you want over what you don't want. So if we want degrees, we're going to multiply by 180 over pi. And by doing that, the pi's cancel, and you just have to type into your calculator, -5 times 180 divided by 3. And this is negative 300 degrees. Next step is we have to draw negative 300. Well, that's negative, which means you're going to start, you always start here. That's 0. This would be negative 90, negative 180, negative 270, and this would be negative 360 if we just kind of kept this going. But we don't want to go that far. Negative 300 puts us maybe over here. And this is quadrant 1. Which, by the way, while we're here, I do ask for the reference angle. We already went negative 300 degrees. The question is how much more until we get to the x-axis? We went 300. The x-axis is 360. So the reference angle is always positive. Connects to the x-axis, less than 90. So 60 degrees would have to be the angle. But you don't want to lose a half point because I do ask you for it in radians. So 60 degrees is nice, but we just want to make sure that we convert it back to radians by multiplying by what we want over what we don't want. And then the last thing is the coterminal angle. So there's a couple different ways we can get coterminal angles. Remember, we said you could add or subtract 360. But one other thing we could do is 360 is the same thing as how many radians? 2 pi. So you could take negative 300, add 360 to it, and then convert it to radians if you want. It's going to be faster if we just take negative 5 pi over 3 and add 2 pi to it. That's going to give us the angle without kind of doing extra steps to go degrees and then back to radians. Similarly, if we want to get radians, we could subtract 2 pi. And on my calculator, the way you would type this in is you just say negative 5 ABC3 plus 2. If you hit enter, you get 1/3, which would be 1 pi over 3. You could also do negative 360 plus 360, which is 60 degrees, and then convert that to radians. You'd get exactly the same answer. And then doing the negative 5 over 3 minus 2 is negative 11 pi over 3. And again, that would be the same thing as negative 300 minus 360 to get negative 660, and then times pi over 180. And that gives us that answer. The answer would be negative 11 pi over 3. Yeah, so what that is that's a mixed fraction, so negative 3 2/3. If you want to write that as an improper fraction, what you do is you take that answer, and then you just hit the second button in ABC and hit enter. What that does is that converts from a mixed fraction to an improper fraction. And you'd get negative 11 pi over 3. We don't want to use mixed fractions. Those are like middle school math. We always use improper fractions. All right, we doing okay? Okay, so I have, it's like 3 problems left. Some graphing to do. All right, the way we talked about doing these problems is you have to make sure that that x is by itself. If there's anything in front of the x, you have to factor it out. So first thing I'm going to do is divide by 2 out of these. And that gives us the equation f of x is equal to 2 times the cosine of 2 times x plus pi over 4. Pi divided by 2 is pi over 4. The amplitude is the absolute value of the number in front, which is 2. I asked for the period in radians. So the normal period of cosine is what? 360. 360 is degrees. I did ask for in radians, so let's just put 2 pi, that's the normal period of cosine. And if we divide by 2, this means the period's going to be pi radians. To get the phase shift, we look at this part of the graph, and this is telling us to go left pi over 4. So what you're going to do is you're just going to tell me literally left pi over 4. And then we have to know what these graphs look like because we have to come up with 5 points. This is the graph of cosine. So cosine normally looks like this. Starts at 0, it's 1, then it goes 0, -1, 0, 1. So this is what cosine usually looks like. We have the first point, second point, third point, fourth point, and fifth point. This graph is just like this, but it's shifted pi over 4 units to the left. So when you go to get your points, remember the way that we do this is we take the period and we divide it by 4 to give us pi over 4. And that's going to give us the 5 points. The first point is the phase shift. This is where the graph is going to start. And it's going to start pi over 4 units to the left. After that, we have 4 points. 1, 2, 3, 4. The way we get those other 4 points is you take the x value of the phase shift and you add pi over 4, giving us 0. Take 0 and add pi over 4, giving us pi over 4. Take pi over 4 and add pi over 4, giving us 2 pi over 4 or pi over 2. And then we take pi over 2 and we add pi over 4. That gives us 3 pi over 4. I'm just going to take a second and pause to see if there's any questions so far. Remember, we start with the phase shift. The phase shift is the first point. And then every point after that, the x value is whatever the period is divided by 4. So that's that. Now, looking at the original graph, we start at 1, then go to 0, -1, 0, and then back to 1. So as far as what this graph's going to look like, we'll go negative pi over 4, go to 1. 0, go to 0. Pi over 4, -1. Pi over 2, 0, and then 3 pi over 4, 1. That's what the graph would look like. That's a full cycle. Anyone have any questions with that? It's a little tricky, but if you have questions, I'll answer any questions that you have.
The amplitude, you said it's the number in front.
So that's a good point. The amplitude's supposed to be 2. So instead of only going up to 1 and -1, it should go up to 2 and -2. Thank you, George. So the graph should look like this. Thank you. Yeah, so if the amplitude's 2, that should be the highest and lowest the graph goes. That's the y value, yeah.
Is it the 2 close or 2
The amplitude's always the number in front, the absolute value of that number. Any other questions with this? We have a couple more. Okay, not hearing any questions, we'll move on to the next one. And then I do have a worksheet. When we're done going over the exam, if you want, you can stick around. If you want, you can go home. But I have an extra worksheet with graphing. We could always practice that if you're a little confused by this stuff. But please keep asking me questions. All right, consider the function cotangent. Now remember, we have to have a theta by itself. Right now, this is saying cotangent of 1/2 theta minus 180. We don't want to have 1/2, we want to have just theta. So we could go ahead and take the 1/2 out. And remember, when you divide by 1/2, you're not dividing by 2, you're dividing by 1/2. That's what the problem would be. What would the amplitude of this be? We don't want to say 0. We don't want to say 1. We don't want to say anything other than nothing. This has no amplitude. All right. Remember, the only graphs with amplitude are sine and cosine. Please don't get that wrong on the test. I'm going to ask you. Please don't put anything other than none unless it's sine or cosine. Now, as far as the period, it looks like this is in degrees. So you have to remember that chart that I gave you in the notes. Everything had a period of 360 degrees, except tangent and cotangent. Their periods were what? 180. Very good. So the normal period is 180, but we're dividing by 1/2, which gives us a period of 360 degrees. Eventually, when we go to plot our points on the graph, what you want to do is take the period and divide by 4, which is 90. This is going to contribute to the 5 points that we get on the graph. All right, but we'll get there in a little bit. What would the phase shift be? So we're going to go to the right at how much? 360. You have to look at this equation, right? The original equation doesn't mean anything to us because we have to get theta by itself. Once theta is by itself, that's the one that we use. So we're going to go 360 degrees to the right. Make sure when you're telling me phase shift, you tell me the direction. That's probably going to be worth a point. And if you just put 360, I have to take off a point. You could write it out, say to the right. You could draw an arrow to the right. But I would like to see a number and a direction. And now we have to try to remember what cotangent looked like. Cotangent, if you remember, started with an asymptote at 0. And then what happened was the graph went like this. For the duration of the period. So it looks like we have the first point's going to be an asymptote. Then we have this point, that's going to be the second. This will be third. This will be fourth. And then the asymptote will be the 5th point. Do have to know where these graphs start at 0, because that obviously that's affected by the phase shift. All right, so to get started, the phase shift is to the right 360. So the phase shift is 360 degrees. All right, to get the next one, we're going to take 360. And we're going to add 90 to it. And if you do that, you get 450. Then you take 450 and you add 90 to it. And that's 540. Then you take 540 and you add 90 to it. Then you take 630 and you add 90 to it. And that's 720. Yeah, I don't think it's going to fit on the graph that I drew, so we'll have to modify the graph. All right. On the exam, it will fit on the graph. So the initial starting point of cotangent is undefined, and then it ends by being undefined. So that we know we definitely have those 2 points. and then it goes 1, 0, -1, and then undefined. So when we go to graph this, just kind of extend this. So at 360, it's undefined. At 450, it's 1. At 540, it's 0, -1, undefined. And that's what this graph would look like. Question?
So I know you said it's not gonna be like this exam, but like hypothetically, if it was like shifted off the graph that we get. If we like drew it correctly, like it would be in the middle, since it does continue forever.
Yeah, I mean, the graph would just really just look like this, right?
So if we drew like that part, instead of the part that's off, of it, we still get credit.
Yeah, that's fine, absolutely. All right. So what the question was instead of drawing the piece that's off the graph, I'm not telling you you have to like start there. I mean, that's how we practiced in class. That's how it'll be on the final exam. But as long as you understand graphs, I just asked you to sketch the graph. If we know the period is, what do we say, 360 degrees, this is what it looks like here. You can just copy and paste that's on the graph. Every 360 degrees, it's the same. Want to draw it off the graph? Perfect. Want to make it fill in? That's fine. Something else you could do to graph these is you could just plot points. So if you were to plug 0 into this equation, 0/2 is 0, minus 180 is -180. Cotangent of -180 is. I mean, there's a couple different ways you can graph this. I think the easiest thing to do is to just do what we've been practicing. Just draw it off the graph.
I just wanna make sure, like if it's like -90 instead of 360, and that one on that side is slightly off, I just wanna draw the left one instead, I wouldn't get points off of that.
Yeah.
Yeah, okay.
So the way that I'm gonna grade this, just so you know, I have the test right here. I'll tell you what my rubric is gonna be. I think it's important that you know. But for a graph like this, the way my grading is gonna be is you'll get a point if you just tell me that there's no amplitude. You'll get a point if you tell me the correct period. If you told me 180 by accident, I take off half a point because you told me the normal period, not the one after it's transformed. The phase shift, it goes 360 to the right. So this is a 4-point problem. And then as far as the graph, what I'm going to do is if you have the correct looking shape, I'll give you a half point. And if the period is correct, I'll give you half a point. So that's how I'm going to grade this. For example, if you drew a graph that looked like this, obviously that's not the right period. That's only 180. The period's supposed to be 360. So does that help you out a little bit more? Right? I'm your ally, right? So I want to try to give you as many points as I can. If I could figure out what you're trying to do, I'll give you the points. If you're wrong, then you're wrong, right? So, all right, let's do number 9. What's the amplitude for this graph? None, thank you. Just to throw you off. But sorry? Sine and cosine, yeah. So the 2 is there partly to throw you off, right? Obviously, there's no amplitude for this. But also, if you remember what cosecant looked like, the normal graph of cosecant started undefined. And then it started at 1. And it kind of looked like this. If you remember when we talked about cosecant, it looked like that. All right, so that's if there was no 2 in front. What do you think having the 2 is going to do to the graph? It bumps it up to 2 and -2, right? So what this graph's going to do is instead of being at 1, Now it's going to be a 2 and -2. Does that make sense? Doesn't affect the amplitude because there is no amplitude. All right, good. I think you guys are understanding this, which is great. We could go ahead and answer these questions because the x is by itself. So there is no amplitude. As far as the period, the normal period of cosecant is what? It's usually 360, but I did ask for in radians. There's nothing to divide by it, so we'll just keep it 2 pi. The phase shift is going to be pi over 2 to the right. And now we have to figure out what the graph's supposed to look like. Well, we always start with the phase shift. And then there's going to be 4 additional points to get a full cycle. It is, yeah. Pi over 2 to the left. Thank you. Plus goes to the left, minus goes to the right. So we're going to start with pi over 2 to the left, which would be negative pi over 2. But if the period is 2 pi, what we're going to be adding to these, remember we're taking 2 pi and dividing by 4. So that's just pi over 2. So we're going to take negative pi over 2 and add pi over 4 to it. You could use a calculator if you want. You could do negative 1/2 plus 1/4 is negative pi over 4. And then negative pi over 4 plus pi over 4 is 0. 0 plus pi over 4 is pi over 4. And then pi over 4 plus pi over 4 is 2 pi over 4 or pi over 2. Now we're going to have 5 points to this. The 5 points of the full cycle would be, the first point is undefined. The second point is going to be right here at 2. Then we go undefined. Then we go here at -2. And then we go right here at undefined again. So it's really important that you remember what the original parent graphs look like. The negative pi over 2 undefined is an asymptote. Negative pi over 4 and then 2 looks like this. 0 is undefined. Pi over 4 is -2. Pi over 2 is undefined. That's what the graph would look like. Yeah. Making all kind of mistakes tonight. Let's see. Cosecant is 2 pi. So we need 360 degrees. We're going to divide by 4, so that's pi over 4. We are adding pi over 4 to each x value. Yeah. 2 pi over 4 divided by, 2 pi divided by 4 is pi over 2. Yeah, sorry, I messed up. All right, well, let's just make the adjustments then. Thanks, guys, for being alert with this stuff. All right, let's fix this. All right, thank you for catching that. So we are going to start at negative pi over 2, but we're adding pi over 2 to everything. So negative pi over 2 plus pi over 2 is 0. And then 0 plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2. And then 2 pi over 2 plus pi over 2 is 3 pi over 2. All right, so let's just correct this then. Negative pi over 2 is still undefined. 0 would be 2. Pi over 2 is undefined. Pi would be negative 2. 3 pi over 2 would be undefined. And now it looks like it's correct because the period is supposed to be 2 pi, and it is exactly 2 pi. Good. Anyone have any questions on this graph? So it's only 7:20. The purpose of today was just to review. If you don't have any questions, you're free to leave. What I'm going to do is I'm going to stick around and I'll go through some more graphing problems and I'll answer any other questions that you guys have, okay? So if you're leaving, I'll see you on Wednesday at 6:30. If you're sticking around, we'll get ready to keep reviewing.
Could you, I don't remember how to put my calculator in the right mode for that.
It's probably under mode.
Yeah.
Mode. Maybe shift. Yeah, so what we want to do is hit the shift and then the mode button. And we want to either pick degrees or radians.
Oh, okay. Okay, thank you.
You're welcome. Yeah, so if what are you trying to do? Are you trying to add these together?
Yeah.
So what you would do is you would just type 1, just put the pi on the end. You would type 1 plus 1/2. 1 plus 1/2 would be 3 over 2. Yeah, the pi is just kind of along for the ride. You're welcome. All right, let me add some more graphing problems here. All right, thank you. Good night. These are 6 graphing problems. I think maybe what we could do is kind of alternate. The first 3 are degrees, and then we have 3 that are radians. So maybe I'll do one of each and then give you guys time to work on them on your own, okay? So for this first problem, the amplitude is 1. There's nothing in front of theta, so the period is 360. And the phase shift is to the right 180 degrees. Now we just have to figure out how to graph this. Well, remember, sine looks like this. So sine has 1, 2, 3, 4. Those would be the 5 points of sine. So when we go to graph this, we're going to start with the phase shift. Phase shift is to the right 180. And then we're going to take, we have to take the period and divide by 4. That's 90. So 180 plus the 90 is 270. 270 plus the 90 is 360. 360 plus the 90 is 450. And then 450 plus the 90 is 540. Oh, looks like this will probably go off the graph too. We could just maybe relabel these if you want. We'll just label this 270. This will be 360. This is 450. And this is 540. So if sine usually starts at 0, it's going to be 0, then up to 1, 0, -1, and then 0. Those are going to be our points. So 180 is going to be 0. Then it goes 270 is 1. 360 is 0. 450 is -1. 0. The graph will look like this.
Now, can we just label them on a graph like you did ourselves? rather than just-
Yeah, that's fine. That's fine. Now the test is going to be single page, so if you just go over on the back, it'll be blank. You could just draw your own graph if you want. All right, so that's that graph. Let's do one with radians. Of course.
Like, like stretching it vertically, like factors,
That's the amplitude.
oh,
You're welcome. Courtney, okay? All right. Anyone else have questions with this one? Let's do one with radians. Cotangent. If you remember what the graph of cotangent looks like, cotangent starts undefined, and then it goes like this. So the amplitude, we're going to say none. Period, there's nothing in front of x, so the period here is just pi, and then we're going to go to the right, pi over 2. So if the period is pi over 2 to the right, that's the phase shift. The period, we're going to take pi and divide it by 4. So our points are going to be the phase shift, and then we have 4 additional points. We're going to start at pi over 2 to the right, and then we're going to just keep adding pi over 4 to it. So remember, when you're looking at the points, it looks like we have one right here, 2, 3, 4, and 5. So the first is going to be undefined. Then we're going to go 1, 0, -1, and undefined. And pi over 2 plus pi over 4 is 3 pi over 4. 3 pi over 4 plus pi over 4 is just pi. Pi plus pi over 4 is 5 pi over 4. And then 5 pi over 4 plus pi over 4 is 6 pi over 4. If we go to graph this, pi over 2 is going to be undefined. 3 pi over 4 is 1. Then pi is going to be 0. 5 pi over 4 is -1. 3 pi over 2 is undefined. And the graph's going to look like this. All right, that's just one cycle of the graph. Okay. Okay. Let's try another. How about when you guys do number 2? I'll give you a minute, see if you could do that on your own. At least just get the amplitude, period, and phase shift, and then we'll figure out the rest together. Anyone need the sign-in sheet? All right, with tangent, the amplitude, we're gonna, even though it says 3, all right, we're saying none. All right, don't tell me there's an amplitude if it's tangent, there's none. The period of tangent is normally 180. There's nothing in front, so it stays 180. And the phase shift is going to be to the right 90 degrees. So the way we're going to graph this is we're going to pick, remember what tangent usually looks like. Tangent usually looks like this. So starting at 0, we have 1 point, 2 points, 3 points is the asymptote. 4 points is down here, and then 5 is 0. So to get these other points, we're going to do 180 and divide it by 4, which is 90. So we're going to start with the phase shift, which is 90. Second point, we're going to add 90 to that. Third point, we're going to add 90 to it. Fourth point, we're going to add 90 to it. Now, fifth point, we're going to add 90 to it. Did I make another mistake? Ugh. I need to sleep more tonight. I stayed up eating potato chips. I know I shouldn't have done that.
You're biting the rest, adjust.
I tried potato chips and salsa. I was just not really in the mood last night. So yeah, 45 is right. So this is going to be 135. This is 180, 225, and 270. Thank you. Tangent starts at 0. Then we go 1 and undefined, and -1, 0. So at 90, it's 0. 135, it's 1. Undefined. -1, 0. The graph's going to look something like this. It's close enough. And we'll do one more. Why don't you guys see if you could practice this one on your own? Let's do number 6. That way we'll do 4, gives you still a couple of practice. I'll give you a minute. Why don't you try that, and then we'll go over it together. Secant, those are alternating parabolas. Tangent would look like a cubic graph. There.
You only need the 2 point.
Well, we picked the 5 points here.
Well, for the shape.
Yeah, for the shape, there's always 5. So you always start at 0. And you just pick like 5 points to get a full period. So if you're starting at 0, first point is 0, right? Second point is going to be right here. Third point's the asymptote. If you'd like, I could show you. Let's go back to the notes.
Well, I'm saying you just.
I guess I just don't understand what your question is. You make it look like it, right? Yeah, I mean, do you need me to explain it more, Mike, or are you okay? You're okay? So let me see. Okay. Oops. Another minute, I'll go over it. All right, so let's figure this out. We can't do anything until we take out that 4. So this is going to be secant 4 times x plus 2 pi over 4 is just pi over 2. The amplitude is going to be none. The period is going to be, well, normal period of secant is 360 or 2 pi. So we're going to do 2 pi divided by 4 is pi over 2. And then the phase shift is going to be pi over 2 to the left. That makes sense? So far, so good. Now, as far as what this graph looks like, secant, you should know where secant starts. Secant is the reciprocal of cosine. Cosine starts at 1. So secant is going to start at 1, and it's going to look like this. Like that. That's how secant starts. Cosecant starts undefined. Because sine starts at 0, cosecant would be the reciprocal or undefined.
Now with this one being effective 4 out, you start at 4.
No, that affects how frequently it repeats. So that doesn't, this right here is where the phase shift is. So the phase shift is to the left pi over 2. So that point right there is going to be to the left pi over 2.
Being the 4 is after secant, it's irrelevant. So
The amplitude, yeah, it would only affect the rise if it was in front. Then that one value would be 4. Does that make sense? Okay, cool. So let's go ahead and figure this out. We have phase shift. Then we're going to add 4 other points. So we're going to start to the left pi over 2. And then what we're going to do is take the period and divide by 4. And that's pi over 8. So we're going to add pi over 8 to all of these.
Period.
You always divide the period by 4. Right? Now I don't trust myself.
Right? You're testing us.
So let's see. -1/2 plus 1/8. -3/8. Again, if you want, you could type it into your calculator. -1/2 plus 1/8.
when you come up with the negative 5.
That's the phase shift. We're going to go left, right? Yep. And then -1/2 plus 1/8 is -4/8 plus 1/8 is -3/8. -3/8 plus 1/8 is -2/8. -2/8 plus 1/8 is -1/8. And then -1/8 plus 1/8 is 0. And our points for secant are going to be 1 right here, 2, 3. Let's see. How are we going to get back to the initial? You have to get 5, so do 1. This is definitely going to be 1. And then a full period later, it's going to be the same. In the middle, it's going to be -1. And then these other ones are going to be undefined. That's probably the easiest way to do it. Right. Whatever the starting value is, that's also going to be the ending value. The third point is going to be directly in the middle. So let's see here. we go to graph this, negative pi over 2 is 1, negative 3/8 is undefined. Negative pi over 4 is negative 1. Negative 1/8 is undefined, so it's really, really skinny. So it'll look something like this.